Today we're continuing the digestive and endocrine systems. We're going to talk about nutrition, and we're at the end of this section we're going to get into the endocrine system, and we're going to talk about how that works. So this is section 35.2. In this section, first we are going to talk about the vital nutrients, the stuff that you need to survive, and then we're going to go into the details of those, and then we're going to talk about calories and metabolism. Are you ready? All right, let's go. The vital nutrients. Number one, vital nutrient, carbohydrates. Do we need those? Yes, we need those. Number two, fats. Do we need those? Some of you are like, I'm not sure. Yes, you do need those. Then we have proteins, we have minerals, we have vitamins, and we have water. Those are the 6 vital nutrients. What are they? Number one, carbohydrates, then, and, okay, we're going to do it without looking. Well, no, we'll do it one more time, and you can look at the screen and look at your notes, but the next time you can't. Number one, 2, 3, 4, 5, 6. All right, you ready without looking? Are you ready without looking? Let's see what we can do. Number one. Are you guys looking? No. Let me take it off the screen. Okay. Number one. 2, 3, 4, 5, and okay, I like that. Sweet. Let's make it happen. Where do we get this from? Where do we get these from? We get these nutrients from the 5 main food groups. Depending on which food pyramid you look at, you might see 5, you might see 6. Some put fruits and vegetables together as one food group. So we have the fruits over here, the vegetables. We have the bread, cereals, rice, and pasta group. We have the dairy here. We have the meat and poultry and eggs and all that good stuff. And then at the top here, we have fats, oils, and sweets. So we eat food, and we get these 6 vital nutrients. Without these 6 vital nutrients, the body can't perform in the way it needs to perform. What was the first one? Carbohydrates. So let's go right there and talk about carbohydrates. An example of carbohydrates would be starches. Where do we find this? We find this in bread, in what else? Pasta, definitely. We find it in cereals. Someone said bagels. We do find it in there. Potatoes, rice, corns, beans, pasta. Those are some examples of foods where we get our carbohydrates. Sugars, we get these in our fruits. Okay, of course you get these in other things too, but fruits would be examples of where you get it. Like what? Soda. Oh yeah, soda has a lot of sugar in there. Then when we take these carbohydrates, they are broken down into simple sugars. And those simple sugars are like glucose and fructose. What's fructose? I don't know. Fructose and galactose. So we take in these complex carbohydrates, we break them down into these simple sugars, and then we can use them to do what we need them for. Okay, when we take in these carbohydrates, some of it is stored as glycogen in the liver. Okay, and we spoke about cellular respiration earlier on in chapter something. I don't remember what it was. I think it was 8. But we spoke about cellular respiration and how we were breaking down glucose and all that stuff and getting energy, getting ATP. Some of this we're getting from the carbohydrates that we eat. So some is stored as glycogen in the liver. Cellulose. Cellulose is another name for fiber. Do we want fiber? Oh, we definitely want fiber. Any one of you guys know how much fiber you should take on a daily basis?
30.
What's that?
30.
It's about 30, somewhere around there. 30 what? Grams of fiber on a daily basis, because that helps things to go through the digestive system well, which is a good thing. So cellulose or fiber is not digestible by humans. Okay, we can't digest fiber. We can't break it down, but it helps things to flow through the digestive system so we can have a good functioning digestive system. It helps eliminate waste. And the foods that we find this in: carbohydrates, pasta, fresh baked bread, corn on the cob. These are some more examples. Carbohydrates. What was the second one? Anybody remember? Fats. So let's go to fats. Let's talk about fats. Fats are essential building blocks of the cell membrane. We get essential building blocks of the cell membrane from these fats. Now, anybody remember what the main component of the cell membrane is? It's one of those long names. It's a bilayer. What kind of bilayer? Phospholipid bilayer. All right, fats are lipids, and we get the phospholipids from the fats that we eat to help build cell membranes. It also helps to make hormones. And we're going to talk about hormones in the next section when we talk about the endocrine system. So stay tuned for that. And it also protects body organs. How does it do that? Well, it cushions stuff. You can see I have a little bit of cushion here. Some of that is good. All right? You want to be able to cushion those internal organs so that they don't get easily damaged. It also protects against cold. It gives you insulation, keeps you warm. That's a good thing, right? Especially if you live here in Michigan. You want to be keeping warm. When we eat the fats and they go through the digestive system, they are broken down. And we spoke yesterday about bile that breaks down fats. And when it breaks it down, it breaks it into fatty acids and glycerol. Okay? We remember we spoke about lipids, and we had 3 fatty acids attached to 1 molecule of glycerol. So now we're breaking down these fats into those components. Some fatty acids end up in the liver, okay? And when it ends up in the liver, it is stored as glycogen. And fats are also stored throughout the body, as you can see. Where do we find fats? What types of food do we get fats from? Butter, okay, yes. Meat, all those kind of things. We have meats, nuts, dairy products, cooking oils. We find fats in those different types of meals. So we spoke about carbohydrates, and we spoke about fats. What was the next one? Proteins. So let's go and talk about proteins. Let me ask you this, see if you remember. What are the building blocks of proteins? Amino acids. Good job. I like it. Proteins are needed to make enzymes. Enzymes are important because all of the chemical reactions that are happening in the body are happening with the help of these enzymes. So to make enzymes, to make antibodies, why do we need those? To keep us from getting sick, to fight off infections and all that good stuff. Hormones, we need those, and we're going to talk about those a little later today. And substances that are involved in blood clotting. Why do we need those again? So you don't bleed to death. Do we like bleeding to death? No. No, we don't like that. So we have these factors that are involved in blood clotting that helps us not to bleed to death. Proteins also form a part of muscles and cell structures. Okay, muscles are made up of a significant amount of proteins, and like we spoke about before, when you're lifting weights, you have a lot of people that lift weights, they're bodybuilding, and one of the main supplements people like to take when they're doing that would be protein supplements. Okay, so they get the protein powder, they mix it up in the water, or some mix it up in milk and all that good stuff. They drink that because what they're trying to do is build muscle. Does that make sense? Okay, so protein is an essential part of muscles and of cell structures, of the cell structures. You already mentioned that the individual subunits of proteins are amino acids. So when we eat them and we break them down into amino acids so that we can use them to build the proteins that our body needs. Some of the proteins are carried to the liver and made into fats and glucose as a last resource. So we can use this, when it's made into glucose, we can use it in cellular respiration and get energy from it as a last resource. Okay, so most of the proteins that we eat are used to make other proteins. The body needs 20 different amino acids. Okay, so it needs 20 different amino acids. However, we are only able to make 12 of those amino acids naturally. So where are we going to get the rest from? The food. And that is why we eat. We eat so that we can get the things that our body needs. And in this case, to get those extra 8 amino acids, we eat food. And proteins, where do we get them from? We find them in meats, dried beans, eggs would be another example, whole grains, and dairy products. Okay, this is where we get our proteins from. Now, vegetarians, some people go vegetarian, for example, and they don't eat meat. Well, of course, that means the same thing. And then they end up with a protein deficiency. Why is that? Well, if you're used to getting your proteins from your meat and you're not eating meat anymore, you need to eat something to replace the proteins, to provide the proteins that you need. So you might want to eat some more beans, some more eggs, or different things like that. So you want to make sure you're getting what you need. Vegetarianism is good, but you got to make sure you get what you need. Make sense? All right. Okay, so we had number 1 was what? Carbohydrates. Then? And then? What was next? Minerals. So let's talk about minerals. We're going to talk about both minerals and vitamins. Minerals. What are they? They are inorganic substances. So these are not organic. And they serve as building material. Not only that, they take part in chemical reactions. So a lot of the chemical reactions that we have in the body use these minerals. Then we have vitamins. And these vitamins are organic, so they're not inorganic like the minerals. These are organic, and they are required for growth and metabolism. Okay, so we have minerals, inorganic, vitamins that are organic. Minerals are used as building materials and involved in chemical reactions, and the vitamins are required for growth and metabolism. Anybody here takes multivitamins? Okay, I'm not the only one. Okay, a few others. Sweet. I find that when I take multivitamins, I feel more energetic. Okay, and we say here that it's required for growth and metabolism. For metabolism is the chemical reactions that are happening in your body, and if you have the vitamins that you need, it can happen better, and that helps you to feel better. There are 2 groups of vitamins. 2 groups. First group would be the fat-soluble vitamins. Ooh, let's see if you remember this. Fat-soluble, does it mean that it's polar or non-polar? Non-polar, that is correct. All right, because if it's water-soluble, then it would be polar, because polar likes polar and non-polar likes non-polar. So we have fat-soluble vitamins, and those can be stored in the liver. Okay, and because they can be stored in the liver, if you take too much, that can cause some problems. It can be toxic if you take too many fat-soluble vitamins. As opposed to water-soluble vitamins, those are not stored in the liver, so they don't build up in the liver, and because of that, they are not toxic. Okay, you take your vitamins, you drink your water, and it washes the excess out. So it's not a problem. So it doesn't matter if you take, some of the multivitamins, you'd see like a certain vitamin, it has 500% of your daily value. Well, if that's water soluble, is that a problem? No, right? Because it's not stored. It just gets washed out. If it's fat soluble, that can be stored in the liver, and that can cause some problems. Water, important or not important? Important. I like this brand of water, Wet. That's good stuff. I've never seen it before. I was looking for a picture of water, and this is the one that I found. I thought it was pretty awesome. Wet water. I like it. Sounds much better than Aquafina. What kind of water are you drinking? Wet water. People look at you like you're crazy. All right, so water, why is it important? Well, number 1, it makes up 60% of the RBCs. What are RBCs? Red blood cells. Good job. Red blood cells makes up 60% of red blood cells. If you didn't know what RBCs are, you can write that in. Red blood cells. Also, it makes up 75% of muscle cells. Okay, so 60% of RBCs, 75% of muscle cells is water. Why do we want water? Well, all of the chemical reactions in the body happen in water. So it's important. Water helps to facilitate chemical reactions. It also helps us to maintain our body's internal environment, internal temperature. It helps to maintain our body's internal temperature. We spoke about how it helps us to maintain our temperature by doing what? Sweating, right? Okay, do you guys remember how many milliliters of sweat the average human produces per day? 900 milliliters of sweat. Isn't that awesome? Yes, it is awesome. Oh, yeah. Okay, so it helps us maintain our body's internal temperature. Your body loses 2.5 liters of water per day. Now, I'm not going to put that in a container to show you how much that is, but just imagine there we have the 1 liter container, the one that we use to show the 900 milliliters. So you fill this up 2.5 times, and that is how much water you lose per day. Not just sweat, so don't get too afraid of that or anything of that sort. That takes into consideration sweat, urine. It takes into consideration, I'm talking right now, I'm exhaling, and when I exhale, what comes out? Water, but not just liquid water. What kind? Vapor, right? Okay, so you're exhaling, and every time you exhale, some of the water that you're producing in your body is being let out into the atmosphere. So on average, you lose approximately 2.5 liters of water on a daily basis. Okay, so now let's talk about calories and metabolism. This is the last point we're going to talk about in this section. The energy content of the food is measured in calories. Okay, so calories, when we talk about calories, we're talking about the energy content of food. Okay, and you hear a number of people say, this is how many calories I take in per day. Anyone know what the average amount you should be taking in on a daily basis would be? 2,000 calories a day. And that's going to vary depending on male or female or active or not as active. What's his name? Michael Phelps. Do you guys know how much calories he takes in per day? I think it's either, the two numbers I have in my mind are either 10,000 or 14,000. One of the two. Is it 14,000? I think that's what it is. And I might be wrong on that, but it's a lot. Why is he not fat? He works out like a beast. He swims for like 6 to 8 hours a day. And that takes a lot of energy. You're burning those calories, and you're not going to gain weight as much as I would if I were taking in 14,000 calories in my food. If I were taking in 14,000 calories, I would not fit in that door. Anyhow, so we're measuring the energy content of food in calories. And calories are basically units of heat. And what that means is 1 calorie, this is the definition of a calorie, 1 calorie is the amount of heat required to raise the temperature of 1 milliliter of water by 1 degree Celsius. Okay, so the amount of energy that it takes to raise the temperature of 1 milliliter of water by 1 degree Celsius, that is what we call a calorie. The need of an individual, like I mentioned, varied from person to person, and it depends on a number of factors. Number one, it depends on your metabolism. If you have a higher metabolism, do you need more or less calories? More. All right? The faster your metabolism is, the more calories you need to take in. If you have a slow metabolism and you take in a lot of calories, it's easier for you to gain weight and so on. Metabolism is number one. Body mass, it also depends on that. It also depends on your age. It also depends on your sex, whether you're male or female. And it depends on your level of physical activity. The more active you are, like Mr. Phelps, the more you have to take in. The less active you are, like Mr. Samuel, the less you need to take in. Not that I'm not active, but in comparison to him, I'm definitely not as active. All right, so in general, males need more calories per day than females. Okay, so men need to eat more, on average, than women. Teenagers, of course, are going to need more than adults. Why? You're growing, you're more active usually, and all that good stuff. So you need more energy, so you need to take in more food so that you can get more calories. Active people need more than inactive people. If you are a swimmer and you do that on a regular basis, you're going to need more. If you are a couch potato, you are a couch potato and you do that for a living, let's say you get paid to watch TV or something of the sort, would that be a good job? Yeah? It would get kind of boring after a while, I think. But anyhow, let's say you're getting paid to sit on your couch and watch some TV. You're not going to need as many calories as the guy that is swimming 6 to 8 hours on a daily basis. What happens if you take in more calories than you use? Well, it's stored. How is it stored? Fat. Isn't that exciting? So if you take more than you need, if you're trying to gain weight, you take more calories than you are using on a regular basis, that's going to be stored as fat. If you're trying to lose weight, you want to take less calories than you use on a daily basis, and that's going to help you to lose weight. So taking in fewer calories than your body can metabolize results in a loss of weight, and the opposite is true. Taking more will result in gaining weight. So in review, number one, we spoke about the vital nutrients. What were they again? Number one, carbohydrates, fats, proteins, minerals, and water. Sweet. So those are the vital nutrients. We went through those details, and then we spoke about calories and metabolism. That is the end of section 35.2.